For the semester, we are going to learn what is a relational database model finally. So you heard about a lot the IDB or the relational DB or IDBMS, relational database. At the time, we are going to define such a relation. Relation quite similar as some students still got confused. Two-dimensional array versus the table or relation. So what is the array? I think the array is the first data structure you learned in your undergraduate data structure course. What is the array? It's a set of series of the
related objects.
It's a related. It's the same. It's the same thing. Actually, the main problem of to accessing such a sequence of the data, if they are not homogeneous, so it's hard to compute the address of the memory. Okay, because the integer used, for example, 8 byte. Or the one element use 8 byte, we can, if we know the base address, then number of the element, the order, the fifth or sixth, then we can simply, the one instruction or two instructions are required to compute the exact location of the data. So because of that, we prefer to use the homogeneous. However, nowadays, the very high-level program languages such as Java or object-oriented language, they support the heterogeneous, the array, such as a list or the vector. Okay, but at that time, the performance will be degraded. So because of that, when we manage the very large, even though the list or the vector object provides something method to find the exact element, right? However, it takes time when we have very large data. So we need the data structure. So that is a relation. Relation, we consider the data as a group. So we simply define. So relation itself is a set of data, as you can see. So we can call the data as a tuple formally, okay, from the previous slide. So formal definition means it's a mathematical term. When Dr. E.F. Coate proposed such idea, he used this terminology instead of the informal terminology. I know you are familiar with this informal terminology, but there is no difference. So mostly when you are using the software or the commercial software, you will see the informal terminology rather than the formal. But when you read the technical paper, they mention the tuple instead of the raw data. Okay, so it's nothing but the group of data. Array is also a group of data, and we will define the relation also group of attributes. Because when we collect the data, we collect the related data that has the name, social security number, home phone number, address, office number, age, and GPA, as you can see. Okay, we have the awkward the data we will discuss later, but mostly each data, each tuple, each row has the same attribute. That is the relation. Okay. However, that relation is different from the two-dimensional array. So we will see what are different. In other words, what is a constraint? What is the rule? Do you remember the definition of a model? What is a model? It's a set of policy, rule, concept, okay, constraint, condition, okay, that define something data structure. It's the same thing. We are running new database model, that is a relational database model. So relational database model simply is a group of data. It's not just a group of data. There exists the condition, constraint, that specify the characteristic of the relational database model. So we will today take a look at such a constraint and condition of relational database model that can differentiate the relational database model from other data structure. Okay. Before that, you guys need to be familiar with such a notation. Okay. So one of the characteristics of such a relation is as we discussed the last time, relation is from where originally? set in mathematics. Okay? In a set, definition of set, element, when we define the integer set is the ordered set. Ordered set means there is an order. 1 followed by 2, followed by 3, followed by the 4. Something like that. However, in our definition, even though we borrow the idea of a set to define the relation, in relation it's not ordered set. So which means even though Benjamin Mayer is the front, there's no specific meaning. Okay? Whether this is a first or this is a second, this is a third. Okay, we consider just a set of data. So it's not considered as an order. Order is not important. However, sometimes we need, okay, make them order. So in application level or the language level, we will address, which means when you select the data, you can sort 1. Because if we consider the order data, whenever do you remember the 4 basic operation of any data structure? Fetch, select, okay, and insert, delete, update. Okay, these 4 are very basic. So any data structure needs such a basic operation. It's the same thing in relational model because it's also data structure. Because of that, database has a select, update, delete, insert. Okay, it's the same operation, same method. Okay, then when we
So if we assign, for example, IDs to every single row, wouldn't that make it order?
So that's what I'm going to say. So if we consider we have the ID here, the social security number. Okay, for example, ID. So if we keep the order, what you guys need to do? Whenever you insert the data, you need to find the exact location. Otherwise, you need to sort the data whenever data are changing, right? Do you remember the sorting algorithm? What is the complexity? What is the bigger in terms of bigger? It's a huge, right? Instead of just appending, which one is easier and faster? Just append or order data? Append. So our main problem to define relation is to manage very large database, right? Very large data. So if we consider order of the data, sorting the data, it takes a long time. It's very hard to manage. So we ignore it. So even though we have the ID 1, 2, 3, 4, 5, 4, 3, or 2, 3, 1, 4, doesn't matter. Okay? When we manage the data, okay, so non-ordered data set. Okay? Unlike the set in mathematics. Okay? And also we usually prefer to use the capital letter for the name of relation. Okay? In database, there is no case sensitive. Okay? Unlike the program language or other operating system, database, the relational database, most of the database management system is not case sensitive. However, unofficially agree that we are going to use the capital letter for the name of a relation. It's the same thing for the table name later. So you probably know about what is a table in database that we are going to create later. So we prefer to use the capital letter. Okay, so uppercase. And for the lowercase, it's the database state. Database state means it's the data itself. Okay, for the data itself, we prefer to use the small letter, lowercase letter, and for the tuple, it's also lowercase letter. Also, in case we have the attribute, a number of attribute. So when we have the number of attribute, so for example, in this example, so we have attribute name, SSN, home phone number, and so on. So to specify the SSN, we can use relation name dot attribute name. So which means, for example, we can use a student dot SSN. That means this SSN is an attribute of student. Why? Because we may have another relation that has SSN. That may be possible. Okay? It doesn't have to be unique for entire database. Okay? Attribute name. So to differentiate, so we can use relation name, not the attribute name. Okay? However, later you will learn, even this is complicated, sometimes too long, so we can make the alias of them. But that is the SQL program language level. So in relation, we can use such a notation to represent the attribute. Okay.
You mean alias as, for example, you say employee that is
Yes.
as something
Yes.
else?
We can use the S, ABC, to represent the complicated name or the long name or the Google calculator. Okay. Then another thing is, I think the last class I briefly introduced what is a domain. Okay, according to the definition of the relation proposed by the Dr. E.F. Gordon, he used only domain. So each attribute value SSN comes from the value of this one comes from where?
Domain.
It's a domain. This domain is kind of a big jar. So for example here, there exists such a big jar that includes any possible social security number. It may not have ABC. This is not the possible social security number, but it has from 000, the 000, 0000 to the 9999, 9999, 9999. This all possible social security number is in social security number domain. Similarly, from name has a big jar domain, so any possible name will be here. So when you create a tuple, when you insert a new data row, you can pick up one of this, one of this, one of this. However, sometimes, for example, the Dick Davidson does not have a home phone number. Nowadays, many families, they don't keep the home phone number because everybody has the cell phone. So at that time, according to the definition of the relation, this Dick Davidson cannot be part of a student. Cannot be data. Why? Because the Dick Davidson has name, social security number, but no home phone number, just address, and office number, age, GPA. That is different from the other. For example, the Rohan Panchar has the home phone number. So all tuples should have the common attribute, right? So why don't you think about the entity, then we can group into entity type, right? If the Dick Davidson does not have home phone number, their format is not the same as this student, right? So to address that problem, intentionally we create the value, even though home phone number doesn't exist, because Dick Davidson does not have the home phone number. So from the home phone domain, there is no the Dick Davidson number. Okay? So at that time, to address that problem, so we can intentionally create the fake value, that is null, N-U-L-L. So null is the value, is existing? No, it's just meaning is not exist. Okay? So not exist means can it be true or false? No, it's not false, it's not true. Because it's nothing, it's not existing. So because of that, in database, Boolean means true or false or null. Okay? So what about how many the null office phone number? Actually, we cannot count null. Can you count the host? No. So what about this one? What is the average of these three values? Average. 2. What about this? Is it 2? What? Total is 1, 2, 3, 6 divided by 4?
No, you cannot
No,
consider.
we cannot consider because it's not existing. You can just ignore. Okay? Null means, so it's a huge problem actually. Many of the developers confuse when they summarize or the average, the value, they count even this one. So it's not 0. Even you cannot measure the value. It's nothing, not existing. However, to represent the nothing or the not existing, we use just a symbol NULL. Okay? Then we can make the same format along the tuples. So home phone number, null, and this one, this one, this one, this one, and office phone number, this. So we can make the schema, name, SSN, home phone number, address, office number, age, and GPA as the schema of student. That is a relation. So relation allow this. Also, why don't you take a look at each value? So this value is atomic. Atomic means it's just one value. We cannot divide it into 2. Okay? But some of the students may be curious. What if I divide the Dick Davidson into first name and last name? What about the address? The street number and street name and street type. I can divide? No. According to the definition of your attribute. Address, this is the address. Okay? It's just atomic one value. And name is according to the definition of the name, it's a name itself. So it's an atomic value. You cannot divide it into 2. It doesn't allow multi-value. Okay? Why? If you allow the multi-value, like the object-oriented programming, when you search the data, it will be complicated. So when you select for example, if you allow the multiple names, when you select this data using social security number, see Dick Davidson or the children's name, so you cannot find the exact data. And it's also very hard to manage. You can manage the data, it takes time to manage such a multi-valued one. So when we define the relation, we do not allow multiple, only atomic value. That is another characteristic of the relational model. Okay. So this is the example of the student relation. So for the student relation, we can use student relation name. And in the parentheses, we can list up the attribute using the command. Okay. Also, if we will see after we cover it. Okay. So we can use such a dot notation, the relation name, dot attribute name. Okay. So we can define the tuple is the combination of the value from the attribute to one domain. This one is attribute to domain and attribute to n domain. We can select one value, one null. Okay, then we can make the tuple. Okay. So there are different types of constraints that define the relational model. So there are 3 types of the relation, but we are going to focus on schema-based or explicit the constraint that define the schema description constraint. So we will see such a constraint. There are 3 main constraint, schema type the constraint in relational model. So one is a key constraint, second is entity integrity constraint, third one is a referential integrity constraint. So key constraint. Can you guess what is a key constraint?
Primary key.
Not primary key yet. key is what is the main purpose of the database? We want to manage the big data, okay, very large data. Then we'd like to search the data. What is the best way to search the data? Fastest way. If we have a key is, we already used the definition of a key in ER modeling. In ER, during the ER modeling, we select the attributes that can identify the specific entity, specific data. It's called the key. It's the same thing. So, in relational model, we should have the key constraint. Key constraint, key attribute. Key attribute means it's a unique value that identifies each tuple. Okay? However, in relational model, it's more details. Basically, it's the same idea as what you think about the key. But in relational model, we formally define such a key. So first, the super key. Super key means, so from this example. So social security number is, as everybody knows, this is a unique value. So when you identify each student, what attribute can be used? Social security number. Using social security number, we can identify the specific. What about name? Can we identify the student social security number plus name? Yes, because the social security number is already unique. So even though we add the name, we can identify. What about name plus address? Social security number plus name plus address. Using these three attributes, we can identify the tuple. This combination of attributes that can identify each tuple is called super key. So, social security number itself is a super key. Social security number plus name is also super key. However, address itself is not super key. Okay? Can you imagine what is a super key? So, how many super key here?
One.
Just one? Why?
The super key is a social security number.
How many? Many. What about this one? This is a super key. What about this one? Social security number plus age. This is also super key. However, GPA plus age is not super key. Okay? So, we can find as many super key as possible. Then, if we select only this one, because the other, they don't affect anything to find that they identify the data. Okay? So, this, the attribute that can really identify the tuple is called the minimal super key. So we eliminate unused the attribute, then we pick up this one, social security number, as minimal super key. Okay? Minimal super key is candidate key. Okay? It's not key yet, it's a candidate key. Here, what is a candidate key? Social security number. What about this one? If I add UBID for the student database, what is this? How many super keys? Many. There are many super keys. And how many minimal super keys? Two. One is UBID, another one is SSN. What is the candidate key? UBID and SSN. Then among candidates, so we can use any of them to find the student. Then how many the chair in the department? One. How many president in the nation? One. So how many key do you want? We need one. Only one king under the God. Okay. So we need to select one of them as a primary key. So, for example, we decide that social security number as the primary key. That's the reason it's called the primary key. It's not just a key. If we are saying that just key, that means candidate key, minimal super key, candidate key. Okay, how many candidate key? One or one more. Okay, it can be two. In this example, it's a two. It can be three. Is it possible to have the relation without key? No. In data relational model require at least one key attribute. So at least one primary key. Okay? So that is primary key. Then, what about the UBID? UBID is still called candidate key, or it's called sometimes secondary key. So you heard about secondary key. What's the difference between primary key and secondary key? It's the same almost. The only difference is one is selected as the primary key to represent the table. The other one still you can use the secondary key to select the data, to identify the data. So it's equally important when you search the data. Okay? So that is a secondary key. Then question. So I identify the two candidate key, UBID and social security number. Then I need to decide the one primary key. How? How can I decide the primary key? Just roulette? Rolling the dice?
Based on the other entities' relationship.
Others. That's also a good approach. Any other opinion?
Which one is more important or which one is
In terms of what?
priority or hierarchy?
Why don't you think about the handout? So you can see the overall process of the database, the application design. The right-hand side, data design. Left-hand side, application analysis. So you can take a look at your application. In other words, your customer requirement, what they want in this database. So this is for student table. Okay. In the student table nowadays, it's illegal to collect the social security number information. But it's old data, so they still have for the student. But let's say that this is only for the student. Which one is more frequently used?
UBID.
Definitely UBID. So we can select the UBID as a primary. But if this is for payroll database, which one will be? SSN, because it's taxable. When you all the pay and the pay stub are related to the tax, it's the social security number actually used for your tax information. So we'd better use this. So you need to decide which one will be better. So by considering the application requirement as well as other table. All other table has the attribute social security number, not UBID. At that time, you'd better use the social security number as the primary. Okay. Another question is, why do we need to consider super key? I can find directly the social security number and UBID as P. Yes, that's true, but sometimes if you do not know, you are very familiar with this database, right? So everybody knows what is a student, and student has this information. What about something, the genome science or the DNA science, which you are not very familiar. At that time, you need to take a look at data itself. Then identify which the group of attributes can identify the data. So you can start from the identifying the super key and minimal super key and candidate key, finally primary key. That is the process. That is the first thing, first constraint of the relational model. Key constraint. Each and every relation table should have at least one key attribute. That is called the primary key. What is a primary key? It's a unique, okay? Unique constraint. Okay. What about this one? So we decide that this is a primary key. I insert this data. Is it okay according to the key constraint or not?
No.
Why not? Why not?
Primary key cannot be null. Cannot
Actually,
be
we define the key constraint. Key constraint means, okay, super key and key. So what each relation should have the unique, okay, attribute, at least one unique attribute. This one, is it unique one?
Yes.
It's still unique because you cannot
have nothing.
compare null with other data. It's still unique. So what about another null? And this is a James. It's a unique one. It's still unique because you cannot compare null with the other. Okay. So key attribute is only uniqueness, key constraint. So to address that problem, unique and
Not null.
not null. So that is the non-null for the key attribute. So key attribute should not be null. Okay, that is called a second constraint. Okay, that is entity integrity constraint. It's a non-null. So that is the reason the key constraint is a uniqueness, and this is a non-null. By combining unique and non-null, that is a definition of primary key. Okay, only selected the primary key should not be null. So that is the reason you heard about what is a primary key. Primary key is the attribute, unique attribute as well as non-null attribute. What about the secondary key? Secondary key is only unique. It doesn't have to be the not null. It can be null, it can have the null data. So when you select the primary key, you need to also check whether null data or not. If there is a null data, it cannot be the primary key. So what is a primary key? It's a key constraint and entity integrity constraint. In other words, unique and non-null is the primary key. Then the third one is key constraint, entity integrity constraint. We consider only one relation, one table. But referential integrity constraint consider two relations. For example, I'm not sure whether we have the good example of the. First, why don't we take a look at the example of the company database, then we can move to the referential integrity. So in this case, the employee is the schema, employee schema, and we select the primary key as the social security number. How many primary key? So only one primary key, so you should be careful. What if social security number plus birth date is the primary key? Yes, that can be possible. That's called composite primary key. At that time you need to connect. Just like the key attribute in ER modeling. Key attribute can be composite. Key attribute you need to connect. There is no another primary key. Okay? Instead, this can be sometimes dot, but you don't have to specify the secondary key. Okay? So department has it and departmental location. Actually, this one should be connected. It's a mistake. And number, I already asked the Dr. Elmasori to change, but he didn't pay attention to. And this should be also connected. So these are the relation. Okay, what relation? Company database relation that satisfied with the first key constraint and second entity integrity constraint. It's none. Then the third one is Why don't you take a look at the employee and department? Employee and department. Employee has the D as an attribute. The department has the D number as a primary key attribute. At that time, is it possible to have we have the department number 1, HR, department number 2, payroll. Is it possible to have the employee who does not belong to this, which means department number 3? No, it's not possible, right? Doesn't make sense. So we have a student who major in the law school. We do not have the law major, right? So all students should be any of this. Okay, this is the another constraint. This is called referential integrity constraint. It's a refer to this one. This at that time this is called referencing. Okay, referencing attribute. This is called reference attribute. So this D and O depends on D number in department. At that time, most of the time, referenced attribute is what? Primary, or at least unique. Otherwise, if we have the two of the same data, two, so this is the admin. We don't know which one is which, right? So that is the reason most of the case, not always, most of the case, the reference column is the primary key of that relation. Okay, at the time this is called the referential integrity. Mostly we can use arrow from referencing to referenced. Okay, so this time, so we can find this, the referential integrity. Can you find any other referential integrity? So D number, refer this one, right? What else?
D now.
D number in the department project to this one, right? Any other? P num in where? Works on. P num is a P number, yes. And ESSN should be in the SSN, right? Others. This ESSN should exist in the SSN. Others. Department.
Name.
Where? Which department?
D name.
D name.
No, dependent.
Dependent.
Sorry. That's dependent.
Manager social security number. Manager is also employee, right? So should be from referencing to referenced. Okay. Anything else? Super SSN. This is also possible. Just like the self, do you remember the ER modeling? In the ER modeling, self-referenced the relationship. So supervisor, same thing. This super SSN should refer the SSN in employee. Somebody may be curious. I think that's pretty much. That's it. Okay. That is called referential integrity. Also, it's well known as the foreign key. So this is called a foreign key. Three main constraints, three main rules in relation that differentiate from the two-dimensional array. First one is key constraint, unique. Okay, you should have the unique, the attribute. And how many? Sometimes you have many. So we need to select one of them. That is also not null. Okay, so not null is the entity integrity constraint. Then third one is the referential integrity. Also, because of this referential integrity, foreign key it is very easy to manage the very large data. We can segment. We can make the entity. Then when we need to access the data, we can later combine. So for example, I'd like to find manager name and department name, like this one, HR lead, and admin John, something like that. Can you get this data from one relation? Is it possible? Where is this name? It's on the here, right? Where is this name? It's on the here. So it's a separate. Then how can? Using manager social security number, we can find the employee whose social security number is the same as this one, then get the person name. You need to access two tables using this foreign key or referential integrity. This operation is called later join operation. So using the join operation, you can retrieve you can access as many tables as possible. Because of that, database language is quite simple and easy to use the first time. Okay? Then somebody may be curious, why don't we combine all the data into one? Okay? Then we don't have to join, we don't have to create such a foreign key. So why don't we combine all this company data set into one relation? What is the problem?
Some attributes might get null, for example.
A lot of null, right? So we don't need this for the employee, right? And also,
These are duplications of the tables.
hard to decide key attribute, okay? Because when we decide the key, it's the non-null and unique. So unique means, from the employee, so we can use the social security number. From department, D number. So each and every relation has a different, the unique attribute. So we can use that. So we can separate. But if we combine all together, if we put all types of students in one room, it's very hard to find the graduate student, undergraduate student. So because they have the different characteristics. So because of that, we are going to manage separately. Then, if needed, we can combine using join operation. At that time, join will be based on the foreign key. Ironically, now sometimes there exists a database system. They ignore foreign key. Why? Why? So for a long time ago, when I was a database administrator, so from time to time I consult the small, medium-sized company database because they didn't hire any database administrator, so they don't manage anything, just purchase and leave it for 5 years, 10 years. So from time to time I was invited and checked the system. Then one time I surprised. So when I asked the EI diagram, it was like the normal diagram like this one, but when I opened the database, they do not have such a foreign key. Instead, just create one table, and fortunately they create a table at the primary key. Okay? What will be the problem? If you use the foreign key, always when you insert the data, you need to check the constraint. All this is a condition. So for example, we have the new employee, but that employee is not assigned any department. Is it possible here? No, it's not possible. Actually, it's possible using the null, but just a simple example. So how can we address that problem? We need to create the department, like the department number 0. Okay, then assign. But sometimes they just insert the data and ignore the foreign key, disable the foreign key. okay, for convenience. Also, it takes some time to check all the constraint. Think about when you have the millions of data, 10 millions of data. Every time when you insert the data, when you modify the data, we need to check all these constraints. So it takes some time. So some of the administrators, they don't like to manage such a foreign key, just ignore it. Then, it may be possible in small database to check such a constraint. How? In application level. In the application level, in your program, check whether this employee is in the HR or the admin or payroll department or not. You can manually check, but it's not easy to manage. So it's also, I think in your programming class, so you just create a table only, okay, and the primary key, but not foreign key, okay. Complicated and sometimes not easy to insert the data, so you can just ignore what is said. When you have small data, it's okay, but when you have a large data, you may not realize the consistency of the database. So that's very important in the database. And join also. Join is very convenient. You can combine as many tables as possible, then select whatever the data is. However, join operation is one of the most expensive operation. What does that mean, expensive operation? It takes long time and it requires space in the memory. Okay, so you should be careful to use. We will discuss more in normalization process. Okay, the problem of such a join, and to address that issue, we can do the denormalization. Okay, so that is the three major constraints. One is a key constraint. Second, entity is a non-null. And third one is foreign key, referential integrity. There are other types of the constraint you can create. For example, I'm the CEO of the company, so all my employees should have the salary less than mine. Okay, that's my constraint. So domain-specific constraint can be applied. There are different ways, but we are not going to discuss detail. But there is a way to maintain domain-specific constraint. Okay. So another example is to get the OPT, the certificate, your GPA should be bigger than 3 points. It's a 3.0, 2.9. 3.0, okay? So in your OPT table, you need to have such a constraint. It's a domain-specific constraint. Domain-specific constraint, depending on the DBMS, Oracle Informatics, they use it different ways. Like the check constraint in the Oracle database, but sometimes you can use the trigger or assertion that we are going to see later. Or sometimes you can manage such a constraint in your application program. In your program, you can manually check. Okay, that is a relational database. Then finally, we can have such a database schema and primary key, non-null and unique. And the foreign key is not here, but with the foreign key, then the data, this is our database state. This is our goal of the project. Okay, you should be able to create such a database that's satisfied with the relational database constraint. Okay, so we already discussed this. Okay. This is the referential integrity that we discussed. Okay. Pretty much I think we covered most of the things. Okay, so other type of the constraint. So we can use the trigger or assertion. What does that mean, trigger? Triggering is when you invoke something action will the event, then action, something like the trigger with a gun. Okay? So, which means this is have you ever heard about ECA rule? Event, condition, and action, which means if something happens, event, check whether that event is satisfied with the condition. Okay, condition. Then do action. If yes, do action. For example, there's a new employee. Okay, so we decide to negotiate the salary. So salary is 100,000. Okay, then that is the event. We try to insert the data. That's the event. Then check the condition. Condition means the constraint, user domain specific condition. So what is the condition? Less than my salary. Okay, so my salary is 90,000 for example. Then action, fire or delete the data. Or you can insert the data, allow insertion, then keep logging and information, notification, something like that. So ECA rule is implemented in the trigger. Trigger is kind of service in the database. So keep running and check the event, define the event, insert of the data, or delete of the student table, or even retrieve of social security number attribute. Okay, then if condition, check the condition whether it's allowed or not. If yes, then do something action. So this is will be implemented the trigger. During your exercise lab, you will test with the trigger. Okay. Then, so this is our relational database model. Relational database model consists of the number of relation. What is a relation? Relation is consisting of the number of attributes. Then number of attributes should satisfy with the condition, constraint, constraint, constraint. Okay, then this is a data structure. In addition to the data structure, we need operation. Okay, after you build a house, you should be able to use that house. Okay, when you define the class, you should be able to use such a class by using what? Method. So you need to define the method. Similarly, we have such an operation. You have seen such an operation where? It's a very well-known operation in general data structure. Insert, update, delete, and select the data, fetch. Okay? So these are also implemented in the relational database model. Okay? We will see details in when we learn the database language. Okay? However, when we insert and delete and update the data, we need to keep what? Constraint that we discussed. For example, when the referential integrity, when we update the department DNO of the employee, so we have the same. So like the DNO is a 5 to 6. When you update the 5 to 6, you need to check what? For this. 6 is not there, so you cannot update. Okay? Also, when you insert the data, new data, you need to check primary key, non-null and unique. You need to check the non-null and unique. Also, if there is any foreign key from here, you need to check. But in this case, no. So you need to check any constraint whenever you are doing operation. Insert, update, delete. Okay. Select is okay, but selection can be managed by the user, the constraint, domain specific constraint. If event is if somebody read this data, okay, then do something. Okay. So that is the database model. This is a quick question. What kind of this is the database relational database model for the bookstore. Manage the book. Okay. So we have so book adoption, student, course, inner, book adoption, and textbook. So primary key is already underlined. In this case, it's a connected line. Okay, and this is a connected line. So then, can you find any referential integrity here? SSN in enroll. This one should refer this.
Course.
Okay?
Course in
Course,
book adoption.
book adoption, course number. Yes, this course should exist here. And book ISBN should be this book ISBN. And course number, this. Any other? Pretty much. But this is not, doesn't have to. Okay? This is not the directory related, so I don't think that's a foreign key. Okay? So, this is the relational model. Okay, pretty much we covered the most of the important thing, the ER modeling. Okay, from information to conceptual design. From the conceptual design, we learn the relational model. Relational model close to what? Database system running on a computer. It's more structured, the model. So the remainder is what? So we have this one, we have this one. Problem is convert from ER modeling to relational database model. This is called mapping. It's just nothing but the mapping. So think about in your project. So after you graduate, you joined one of the big projects. So your project manager hired someone who can do the ER modeling. So conceptual design over here. So mostly consulting firm, like the CPA or the Ernst Young or the something Fitness Bowl. So such a consulting the company can do the ER modeling, conceptual design. Then they will give the conceptual design to the database architect or database designer. Then they need to convert this ER diagram to the relational database model. How can we do that? As you probably realize, this ER diagram is quite similar as this one. It has a key, it has a primary key, right? It has a relationship. Actually, it's not foreign key. Don't be confused. Foreign key is not a relationship, okay? And but there are quite similar things. That is the reason we select the ER modeling for the conceptual design. So we will see how can we do that in next chapter. So this is your homework. Exercise the 5.11 by next week, Monday. So why don't you, you don't have to submit to the Canvas. There is no submission site that will be opened. Instead, you can bring your answer to the classroom. Okay? So it will be good practice for you guys. Then, the next chapter, we will convert the ER diagram to the relational database schema. Okay, so it's a step by step. Our goal is from this ER diagram, okay, to the the relational database schema diagram. This is called the schema diagram, okay, to represent the relational database model. This is our goal. So how can we do that? It's just follow the step by step. The first thing is we have the entity. Okay, from here, what is the entity? This rectangle, this one, and this is a weak entity. So we will take care of the weak entity later. So, what will be the things in the relational model? Each one employee will be employee relation, and department will be department relation, and project will be project relation. So for each regular entity we can create the first step, regular entity. So regular entity is what? Relation. Weak each attribute will be attribute in the relation. Plus, among key attribute. How many key attributes for each entity? Sometimes 0, sometimes 1, sometimes many. But regular entity has at least one entity, right? We need to select one of them as the primary key. Okay? So for example here, it's obvious social security number is the primary key of the employee. And here, the name and number. Which one is better? So I try to select the number in this case. Why? There are not much difference. However, when you compare the data, which one will be faster? Number is the faster. That is the reason we prefer to use the ID number, okay? Or the artificially created the key. Do you remember the surrogate key as the number? So we can use. I decide to use this one. It's the same thing. The department number. Okay. So we can create the relation with the attribute. We will select the one primary key. Okay. Very simple. That's it. So we can create employee, social security number, and underbar and other attribute. What is department and attribute. At this time, if you want to, you can change the name to represent correctly the meaning of the attribute. So we can use a still number, but we have so many different numbers. So why don't we use a D number? Then easily recognize what kind of number is this. D number and underbar others and the project. Is the P number, similarly, then other evidence. That is the first step. Okay? So for the regular entity, we can create and for each entity we can create the relation. Okay, then we select the attribute and primary key attribute. Okay. The next thing is the weak entity. Weak entity, as you can see, there is one weak entity dependent. What is a weak entity?
It doesn't have a primary key.
It's not primary key. Primary key is used in the relational model.
Okay,
It's an entity has partial key or no key attribute. So in this case, the name is the partial key. How can we make it as a regular entity? Using identifying relationship, we can borrow the key of this attachment, social security number, and as the name. So which means the dependent what is this? Social security number. If you want to specify what kind of social security number, employee social security number. Doesn't matter, SSN or ESSN. And name. Dependent name is composite primary. Then, don't forget this one depends on one. So we can create the foreign key, referential integrity, for the identifying relationship. And also don't be confused. Starting from ESSN of dependent to the SSN in employee. So direction is very important. Who is referencing, who is referenced. So in your exam, many of the students complain. I knew the answer, but mistakenly I used a different direction, but it's totally different to me. Okay, be careful. So this is a weak entity. Okay, it's very simple. The first step is the next step, weak entity. Weak entity, how can we handle? So create the relation with composite primary key. Okay? And also we need to create the foreign key for the identifying relationship. That is the second step. Okay? Here, so weak entity. So we can handle the weak entity to create the relational model. The third step is a relationship. Okay? How many different types of relationship? One-to-one? One-to-many? Many-to-many. So first, one-to-one relationship. What is a one-to-one relationship here? Many. Okay, we have the many one-to-one relationship. There are 3 different ways to handle one-to-one relationship. So, for the one-to-one relationship, first one is, because it's a one-to-one, why don't we merge these 2 corresponding relationships, other entity? What does it mean? Because think about the 2, the set is a one-to-one mapping, right? Because it's a one-to-one, you can combine into one. For example, if we have the EMP and department, okay, EMP and department, just one, using one. It's a manager, SSN, and SSN. Using 111, manager, SSN is 111. We can combine EMP on the DPT table. We can combine. That is the one option. So merge. Second, create another relation plus 2 foreign key. What does that mean? So we have the employee and department. We create the manager. Okay, manager relation. Then, what is the key of this one? SSN, ESSN. What is the key of this one? And D number. And composite and SSN D number. And then at this time we can put the start date here. So we can create the in-between relation between this one and this one. Then create the 2 foreign key. That is the second option. Third option, just 1 foreign key. Which means from improve, why don't we use this one? From department we have the manager, SSN, this. Then move any attribute to the either this one or this one. Because it's a one-to-one mapping, it doesn't matter. But which one is better? This department or employee? Department. Why? Because not all employee has a starting date as a manager. Okay? But each department should have one manager, and one manager has their starting date. So we'd better move the start date to here. That is the third option. Which one is better in this case? The last one. I already used it here. It depends on, okay? For example, because it has also the works for employees pretty much larger than this one, so if we combine a lot of null data you have, also it violates the foreign key layer. And if you separate this, it's too much additional information. However, you can select this option if your application access a lot. Okay, 99% of your application access the manager information separately. Okay, at that time you don't have to join the table. Instead, you can create the in-between table. That will be faster. Even though it's a little bit duplicate information, using the foreign key you can still manage, and also you can. However, in this case, I think the foreign key is set because we don't have many the attribute for the one-to-one. So we can use the start date in the department attribute. So we select this option for this. But it depends on. So that is the one-to-one And next, one-to-many. One-to-many, we have this. We have this. We already did this one. We have this. How can we address the one-to-many? Just create foreign key. We have the referential integrity foreign key relationship. So in this case, we create the attribute referencing attribute DNO here. That is works function, right? And what about the control? Control. So in the project, it's a DNO and controlling department. Like this. Be careful. Which one is the referencing? Which one is the reference? Referencing is each department number in employee refer the number in department. It's a many side, one side. Many side, one side. And what else? Supervisor. So we have super SSN refer SSN. Okay? That is the mapping of the one-to-many. One-many-to-one relationship. Very straightforward. The next, many-to-many. It's a tricky. Many-to-many is a tricky. What about we have this many-to-many? The works one. This one. Yeah. Can we create just one foreign key? No. For this, doesn't make sense. So to find the specific, how many hours does the employee, the lead, works on specific project. At that time, these hours is for what? Per employee and per project. So it cannot be either this one, it cannot be either this one. Okay? You need to create another relation. That is the name. Why don't we name a workshop by following name of the relationship? Then this is what is the key of this one. To identify the number of hours, you should know employee. You should know project, which means ESSN plus PN. So it's a composite primary key. Then create the this, then add hours. Anyone who realized that this function, this mapping the function in the Orwin software, in Orwin software, do you realize that this in between table relation? When you create the many-to-many relationship, what happens? There is an option. Why don't you right-click the many-to-many relationship after you create the in the ER Orwin software? Why don't you create the two relationship? Okay, two the entity. Then why don't you create the many-to-many relationship? Yeah. Then you have the option whether you change it, this one or not. Okay, you can any many-to-many can be converted into one entity and to the relationship because of this. Okay, so many-to-many relationship is a relation. Create the relation with two foreign keys. Okay, so that is the steps. So pretty much we create such a database model. Any miss? So we did this one, and this one. What about this? Double over. Location. We can put the location as this one. No. Why? Because relational model does not allow multi-value, only single value, atomic value. So no way to create the attribute. Instead, for the multi-value, we need to create another table, another relation. Okay? What is the primary key of this one? It's that each department has the location. This is the primary key. If there is any other attribute, if you can find, then you can add it. So this DNO is go to this one. That is the reason when you design first time conceptual design. So you expect 10 entities, 10 tables, but after you create the relational model, number of tables increase a lot. Especially for such a small table. It's called sometimes code table. Okay? In object-oriented concept, it can be part of the object. Okay? You can create this object, then this will be part of this object. However, relational model does not allow such multi-valued one, so we need to create. Whenever we need to create a table. So this is the characteristic of the relational model. So you will realize at the end of the project, so your number of table is much larger than you expect at the beginning. So mostly we covered multi-valued. Okay. I think the time's up. Okay, so next class we will discuss the rest of the part, that is the NRE relationship and also the super and subclasses. So how to convert such a super and subclass to the relational model. Okay, so don't forget to submit your homework by the next week Monday.